Edx M2 January 2011, question 7 on moments and equilibrium. Here's the question. Pause the video as usual and take a moment to read it and copy the diagram down and put in the forces that are acting on the diagram. Okay, here we go. Right, there's my attempt at the diagram, and also on the right hand side of the page I've used the fact that sine alpha is a third to find the exact value of cos alpha, because we'll need that as well. Now over in the diagram here we've got a simple normal reaction here. Okay, it's a smooth cylindrical drum, so there's no friction, so it's just a normal reaction. At the ground we've got friction and we've got normal reaction. Now the question simply says find the least possible value of mu. So the friction, we know the friction is less than or equal to mu r. Let's just jot that down. Friction is less than or equal to mu r. The method I'm going to use to find the least possible value of mu is to say that if mu was at its least value for equilibrium, it would be on the point of slipping, and this frictional force would be equal to mu r. So rather than introduce friction as the letter F, I'm just going to call it mu r, since after all it's mu that we're trying to find. Okay, that's the problem we've got to solve then. There's three unknowns, S, R and mu. There's three equations, moments resolving vertically, resolving horizontally. It's just a matter of being careful and carrying it out. So let's get the resolving out of the way first of all. Resolving vertically, we've got S cos alpha plus R equals 100. Check that. And resolving horizontally, we've got S sine alpha is equal to mu r. Okay. Now that doesn't seem to have got us very far at the moment. Obviously we know alpha, so we know sine and cos alpha, we can put that in. But if we look at the third equation, the moments equation, that's going to give us S directly, because that's the only unknown that will come into this equation, so long as we take moments about A. Yeah, well there's A, where the plank's on the ground. So moments about A, well S times 3, that's easy, that's anti-clockwise, and that must be equal to the weight of the plank, which I've drawn there. It was a uniform plank, the weight's at the centre. 100 times the distance, which is 2 cos alpha. 100 times 2 cos alpha. Putting cos alpha in as root 8 over 3 gives us S equals, you can check this, S equals 200 root 8 over 9. That's that done. So we know S. Let's go to the next page, get some more room. So S, don't really need the diagram again now. S is 200 root 8 over 9. Now from the resolving equations, R is 100 minus S cos alpha. So we can work that out. It comes to 100 minus 1600 over 27, which is 1100 over 27. Again, use your own calculator and check that. That's what I'm getting R. Let's just quickly jot them in. That was your R. That was mu R. We've got the weight there and the other reaction there. That was S. That looks better. Now, that's R. We know mu R from the resolving horizontally. Mu R was S sine alpha, wasn't it? Yeah, S sine alpha. You can see that in the diagram above. So mu R works out to be 200 root 8 over 9 from the previous page times sine alpha, 1/3. Okay, so putting these two things together then, mu times 1100 over 27, which was what we found R to be, is equal to 200 root 8 over 9 times a third. Now if you unscramble all of that and use your calculator carefully, you get mu equal to 2 root 8 over 11, or if you'd rather as a decimal, 0.514. And that's the answer. So let's look at the marks for that question. Right, so looking at the first part of the question, there was method and accuracy marks for the resolving. Let's do this in red. M1A1 for resolving vertically, M1A1 for resolving horizontally. Okay, for the moments, also an M1A1. Right, so 6 marks so far there. And then for the, on my next screen here, for finding the value of R and putting in the equation mu R equals S sine alpha, we had an M1 here and then an accuracy mark for finding mu. That's the remaining 4 marks. Okay, so that's that question finished. Just to stress, what I've done is assumed that friction is limiting, because that will give me the least possible value of mu for that to be in equilibrium. Okay, thank you for listening, and there's some information about the Further Maths Support Programme.